So these are the notes about climate and climate change. So main things to figure out here, climate is a long-term weather pattern. The Earth has a variety of climates, and climates can change suddenly or slowly. And about climate being a long-term weather pattern, the main factors that influence climate are latitude, so how far away you are from the equator, or close to the poles, essentially. You can either be close to the North Pole, close to the equator, close to the South Pole. Altitude means how high up into the atmosphere you are. If you've ever gone to the top of a mountain, either in winter or summer, perhaps there's snow on the top of the mountain, but when you get down to lower elevations, there's no more snow because it stays colder the higher up you go. And distance from large bodies of water. If you don't know already, you will find out in the unit that the closer you are to water, like our temperatures where we live, we stay a lot warmer in the summer and cooler, or excuse me, a lot warmer in the winter and cooler in the summer because we're closer to the ocean. And remember, the oceans are the greatest storehouse of heat. So those hold the temperature a lot longer. So the closer you are to the water, the harder it is to change the temperature. If you know anybody that lives in the Great Plains area of the U.S., in the middle of the U.S., it gets there really hot there in the summer. We're talking like 100 degrees easily. And then in the winter, it stays really cold. They get a lot of snow because they're not near any water. And then ocean currents. We talked about how the Gulf Stream comes up from Mexico and comes up past us and brings us our weather. So we're also affected by ocean currents anywhere around the world as well. Seasonal changes are also part of climate patterns. This is a picture of some rice fields, and you can see dry season, it's all brown, versus the wet season, everything's all green. Climate, the characteristic weather conditions in an area over a long period of time. Again, let me emphasize long period of time and its characteristic weather conditions. Weather is different than climate. Climate is over a long period of time, whereas weather is what happens day to day. Latitude is the distance in degrees north or south of the equator. And remember, the equator is 0 degrees latitude, and then if you go up, you're going to the north, and the North Pole is 90 degrees, and then if you're going south of the equator, again, the South Pole would be 90 degrees. So the further away you are from the equator, the higher your latitude number will be. A marine climate is a climate influenced by a nearby ocean, generally mild temperatures and steady precipitation. And these abbreviations you're going to need to know. M is going to stand for maritime. Maritime and marine are very similar, meaning water. P for polar, so we're talking about cold. And T for tropical, so we're talking warm. Continental climates, a climate that occurs in the interior of a continent with large temperature differences between seasons. So C for continental, again P is for polar and cold, T is for tropical and warm. So we're talking about dry, warm air or dry, cold air. And then here on the map, if we wanted to label, we would say A is from land or water. Hopefully you're saying water. And is it going to be cold water or warm water? It would be cold water because we're talking about Alaska here. So this would be a maritime polar air mass, whereas B is over land. It's still cold land though. So now we're talking continental polar, or CP. Back over for C, we're looking at water that's warm. This is kind of near the Caribbean. So warm water would be maritime tropical. And then here with Mexico, we're talking about warm land, so continental tropical. An ocean current, a stream of water that flows through the ocean in a regular pattern. We just finished up the oceanography unit. So think about the ocean currents from that world map that we looked at with all the red and the blue on it. And then we talked about the Gulf Stream as being the main one that affects us. A season is a period of the year associated with specific weather conditions. When we say winter, we always think cold temperatures. And then when we say summer, we always think about warm temperatures. So warm temperatures, we think summer. Cold temperatures, we think winter. That's a season. Scientists usually group climates by temperature and precipitation. There are 6 major climate zones. Climate zones can be divided into subclimates. And then microclimates are even smaller than subclimates. So micro, we know, means really small. So microclimates are the very tiny areas. So taking a look here, all the different colors represent a different climate. And a lot of the times you can see how they're affected by latitude. You've got the equator that comes right through here, where all the red is. And then as you move up away from the equator, that changes the weather as well as the climate. And then a climate zone is one of the major divisions in a system for classifying the climates of different regions based on characteristics they have in common. So essentially, if it's an area maybe that's always hot and dry, that would be a climate zone. Again, thinking about that map we just looked at. Or an area that's always wet and cold, maybe that could be another climate zone as well. A microclimate is the climate of a smaller area within a subclimate. An urban heat island. Let's think about that for a second. Urban means city, heat, and then we know island. So essentially, this is a warmer body of air over a city. If you think about all the pollution that a city has, that's going to create the greenhouse gases that we've talked about before, and then essentially insulates a city more than a country area. And then the rain shadow. This is going to be really important for you to know as well. With a rain shadow, an area on the downwind side of a mountain gets less precipitation than the side that faces the wind. So if you watch the weather on the news, we know that weather is going to move from the west to the east. So the cloud here is moving again from the west to the east. So this represents, if we think about maybe the Rocky Mountains, moist air blown from the Pacific Ocean. So this cloud is coming in from the Pacific Ocean, which would be over here. And as that cloud moves through, it hits a certain area where the mountains are taller than the cloud is. So in order for the cloud and the air to rise up and move over that mountain, it's got to drop out all of its precipitation on what's called the windward side. And I always put this together as windward, wet, and west, because that's always going to be the west side. It's always going to be called the windward side, and it's always going to be the side with the precipitation, so wet. So the W's go together. And then in order for that air to move over, it dries out, and then the leeward side of the mountain is the dry side on the east. Natural events such as eruptions of volcanoes can change the climate. If you guys remember it a few years ago, one of the volcanoes in Iceland was erupting, and all of the ash from the volcano was getting carried up into the jet stream and put out over all of these other countries that were far away. And then it was grounding some commercial airplane flights because, again, this stuff is blocking out the sun, carried up in the jet stream, affecting flights, and it can change all sorts of other events as well. Human activities that release greenhouse gases are also changing the climate. So take a look at the pictures here. These ice sheets on a mountain in Peru has shrunk by 820 meters in 19 years. So over here, here's the glacier, the whole outline of the glacier, whereas look at it now, this is all water. And then that is just a little tiny bit of the glacier left now. An ice age. We've talked about these before, but again, a period of time during which surface temperatures drop significantly and huge ice sheets spread out beyond the polar regions. So everything's turning to ice. El Nino, a disturbance of wind patterns and ocean currents in the Pacific Ocean that causes temporary climate changes in many parts of the world. So if we take a look at the picture here, we've got El Nino conditions. Again, remember that from when we talked about off the coast of Peru with the anchovies back in the oceanography unit. And we talked about when El Nino happened, there was no more upwelling. So here we've got the thermocline, that drastic drop in temperature. And the thermocline is not as drastic here. You've got, and on your notes, you've got space to write this stuff down. El Nino versus normal conditions. Take a look at why the pictures are different. Here you've got this convection cycle happening in the middle of the ocean. So this is the U.S. right here. So the convection cycle is occurring in the middle of the ocean. And you've got all of the warm temperatures in the middle of the ocean. The thermocline is not as steep. Whereas over here with normal conditions, the convection is happening more along the west side of the ocean basin, and the thermocline is a lot steeper. And then here we've got the La Nina conditions. So we need to compare the La Nina conditions back to the normal conditions here. So La Nina, again, take a look. The convection current is very similar in its placement here. So they're the same placement-wise for the convection cycle. But take a look at the thermocline. Look how steep that thermocline is versus here. So the big difference there is that the La Nina thermocline is much steeper. And maybe you can see a second difference. That's generally the main one that I notice. And then something else that I just noticed about the El Nino conditions is that the water is moving to the east, whereas under normal conditions, the water is going to move to the west, and that convection current rotates clockwise, versus during El Nino conditions, you've got the two, and they're still going to rotate clockwise, except that's happening in the middle of the ocean, where the water's moving to the east instead.